Nice. Okay, so today we are going to learn how to set up MazeSolver. And full disclosure, I want you to know that like the origins of the idea for this project and the solution for this project comes from Java Foundations. Shout out to John Lewis, Peter De Pasquale. Sure, I butchered that. And Joseph Chase. They provided the solution in Java. What I have done is convert that to JavaScript and add that graphical interface. So I've built on it, but the basic logic of solving a maze comes from that book. And let me go ahead and share my screen. Here we go. All right. Oh, yeah, excuse me. All right. Sorry, family barging in. Okay, so you should be seeing a slide. I do have a couple of slides. Don't worry, this is not going to be like full PowerPoint presentation, but I did want to hit the topics that we're going to cover. Just know that the three things that I'm hoping you can take away from this: learning how to read from and write to a text file, which is a pretty useful thing to be able to do. Stacks and how they can be useful. We talked about stacks, but it's kind of a confusing topic, so hopefully it's helpful to go over it again. And also recursion. And here's the thing, I'm not sure if we'll be able to get to the recursion solution today, or whether that might have to be something that I do as an add-on. I can certainly send you the recursion solution if we don't get to it today. Because the recursion solution, as we'll see, is the best solution. It's the solution that will allow us to actually not just know whether we can traverse the maze, but also will allow us to know how it is that we got out of the maze. And I want to go ahead and just a reminder of what it is that we're building in case you didn't have a chance to check it out. The basic maze solver, you start off with this, you choose a file, and it's just a text file that contains letters that represent the maze structure. And we'll look at those text files in a second. Somehow we're in my resumes. Let's see, we'll go here, MazeSolver, and text files. You should have all of these text files. And let's open up this one, text file 3. Click open. And there it is. Okay, so the objective of all of these mazes is to be able to go through these clear areas, the white squares, and to find a way down to this lower square, which is your way out. And then you solve, and the red represents all of the spaces that you explored, and the gold represents the path that you eventually found to work your way out. All right, so that's what MazeSolver is going to look like. Any questions so far? All right. Cool. So let's just start by talking about the stack, and I'm going to go ahead and shift over to my code. Let's shut this down. Come on. There we go. Okay, so somebody just want to remind me what a stack is, the idea behind a stack?
So stack is like a stack of papers, first in, last out. Yeah.
That is correct. Nicely done. Yeah. So we just, it's a data structure in which you put something on, you put another thing on, you put another thing on, and then you start pulling those things off. And in JavaScript, the basic arrays already have a lot of that same functionality. So really, when we build a stack in JavaScript, we're actually sort of looking to eliminate some of the possibilities, some of the things that we don't want to be capable of doing, right? We only want to be able to pull information off of the top. We only want to be able to pull values off of the top. And so if we wanted to set up a stack, the first class, and I believe I've given you this in its entirety. For a stack, we have a constructor, which is just going to be an array representing the item. So we just say this dot items is assign the value of an empty array. We want to be able to push items, which means to add them onto the stack so they go on the top. And we say this dot items dot push, and then we put the item in, right? So items is an array, and items already has a push method, or sorry, the array already has a push method, so we're just using that method in the push method for stack. And same thing with pop, right? We want to make sure that we do have items to pop off. Pop is taking it off of the top. And if we don't, we return this string underflow to let us know there's nothing left to be taken off. Otherwise, we are returning using a pop method from the array class, so from items. And what does peek do that's different from pop?
Peek just lets you see what's next on the stack, like what the next thing would be, but you don't actually do it. You don't actually remove it.
Exactly. Yeah, we look at the item that's at the top of the stack without removing it. So that's what we have here, just pulling the item that is at the end of the array, which the end of the array represents the top of the stack. We got some helper methods, just letting us know if the stack is empty, and also a toString method that just prints all of the items in the stack, starting with the bottom of the stack.
Can I ask
Okay,
a
so
kind of a conceptual question about this? And it's kind of a little one of my struggles with this is where like can you just explain the thought process of like when you receive this as a problem, like what would lead you to think, you know what, I need to use a stack to solve this. I think that's going to get me there in a good way.
hmm, that's a good question. I think, and Matilda, you might have more experience with this and might be able to jump in as to certain things lend themselves to that logic. You know, as often occurs in programming, if there's a real life thing that has that behavior of like the last thing in is the first thing out, then modeling that using a stack is probably appropriate. In this case, as we're solving for a maze, we want to be able to test different positions and also have other positions lying in wait to be the next thing that we check. And so once we sort of walk through the logic of testing those positions in a certain order, we'll see why the stack is a useful means. But yeah, you do sort of have to be familiar enough with data structures to kind of think about, oh yeah, this would be a good time when I could use stack, or this would be a good time for me to use a queue. So I don't know, Matilda, do you have anything to add on top of that? I know it was not a great answer.
I'm sorry, I took a phone call during that.
Oh,
so
that's okay.
I'm not sure everything that you covered.
I was just saying, Sean asked a good question of like, how do we know when a stack is the right thing to use, or any of the data structures?
Yeah, like are there any like
Oh,
call outs like in like if I just kind of heard a couple like words in that problem, like you're gonna be given this and you're gonna do this, that I would immediately be like, oh, you know what, a stack's probably great for this.
yeah, you wanna think about like it's how you interface with the data structure, right? So if you just have like a hash, for example, a hash has a constant lookup time no matter which item you're looking up, but you need to know exactly which item you're looking up, right? But a stack and a queue, you don't need to know anything about the item you're looking up. You just need to know that you just need to know like that it's either on the end or the beginning. So with like a stack, like we usually implement those in JavaScript, we would implement a stack using an array. And the reason that we do that is because we have those push pop methods for arrays. So when you push something onto an array, that's constant time. It happens super fast. When you pop something off, it's also constant time, super fast. But when you have an array in JavaScript and you want to use like shift and unshift to interface with the beginning of the array, so the 0 position, you actually have to re-index the entire array, and it becomes a linear time complexity problem, linear to the size of the array. So like for a stack, you want to think about like, okay, do I want to re-index everything every time no, you never want to do that. So you just need to ask like, do you ever need to know like any information beyond like the first element on the top? And that's when a stack is appropriate.
Cool. Thanks, Matilda.
Yeah.
I want to jump in. You all can explore these text files. Like these are the basis on which we build the maze. And so, right, you want to be able to store different mazes, and you see they're sort of increasing complexity as you go through 1, 2, 3, and 4. The ones represent an open space, and the zeros represent a barrier. And so you see in this very simple example, right, these first two numbers tell us the number of rows and the number of columns. And then the remaining rows represent the actual pattern. And so in this very simple example, you can see that you could solve this maze by starting in the upper left-hand corner. You work your way down through the ones, and then it's solvable because you can move through those ones all the way down to the lower right-hand corner, right? That's what defines solvable for these mazes. And so the question that we're trying to answer with MazeSolver is there a path through the ones that takes us from this 0, 0 position all the way to the end? So let's go ahead and jump in with some code. Actually, one more file that I want to take a look at, just kind of a utility file here. You've got this class called position, and position is just intended to group together an X and a Y coordinate within that maze. So we've got a constructor that just assigns a X and Y that are local to the position object. We've got an accessor method getX that just gives us the X position and 1 for Y. We can set the X, we can set the Y. So just know that when we're referring to a position object within this program, like this is where that's coming from. So pretty straightforward. All right, the first file that we need to work with is going to be maze. Actually, let me take a step back. Sorry. And before we look at maze, I want to just look at script, because script is kind of where this program is starting from, and we should just realize what's needed to sort of set this up. And I've given you this file in its entirety as well. Let's just walk through it. These are just things related to the HTML right? This is just stuff that's showing. So I'm not really going to focus on that today. I just want to focus on the logic. So this is kind of our main, right? Kind of our main method. We need a grid. We need a maze. We need to keep track of the number of rows and the number of columns. We need a stack. And we need some Boolean variable to let us know whether the maze has been solved or not. So those are the different variables that we're going to be working with in this program. This is just what allows us to open up the appropriate file that we're running. And this is just stuff associated with the button. I'm going to skip through that. Again, I really just want to focus on the logic of reading the maze. Okay, so this is the event listener. This is what happens when I click that button that says to go ahead and solve the maze. So this is what I want to focus on. We have a class available to us called file reader. And when the reader is loaded, we want to do the following. We want to assign to our grid reader.result. So the reader.result is the file that we have selected, .split. And then what does this /n character mean? What are we doing with this .split function?
I would say you're generating an array of values that represent, like, each element in the array is a single line of the text file because the /n is a new line character.
Exactly, yeah, thanks, Matilda. Right, we're just breaking it into an array of lines. Each line in that text file is now stored as an element in the array. And then we take that line right here, and we are splitting it up. Again, breaking it down into another array. So we have an array of arrays where the different elements are separated by spaces, and where we're taking each value and converting it to an integer. So this is the code that we need to take that text file and to convert it to a two-dimensional array of integers. And what was on the first line of that text file?
Yeah, that was the height and width of the maze.
Exactly. So that was just like if we are reading grid sub 0, 0, that's the first number on that top line. So we assign that to num rows. And the second number on that top line can be accessed at grid 0, 1. And so that gets assigned to num columns. So now we've identified the number of rows and number of columns. And once we've done that, we don't need that information anymore. And we want to make sure that that is not read as part of the maze, which explains the next line. If I do grid is assigned the value of grid.slice 1, -1, I guess the comment, I won't ask you since the comment tells you, but slice removes portions of an array that we no longer want. So by saying 1, it means start at 1. So we're going to eliminate the 0 row, that top row. And we're also going to eliminate the last row with this -1. That's just because there's this extra line that gets read from the text file. It's just an empty line, but it's enough to throw off our maze reading. So that's why we have this code here. All right, I put in some outputs. It's pretty helpful to be able to just follow along with what's happening to your grid by looking at the text of it. And here I'm instantiating a maze object, which is the next class that we're going to look at, or that we're going to write, actually. Solver, okay? We actually MazeSolver 2 is the recursive one. So I forgot we should change this to just MazeSolver. So go ahead and make that change in your code. And you pass in the maze. Obviously, MazeSolver needs to know which maze it's working with. And again, this is sort of display stuff, so we're not that concerned about that. So we can say if solver.traverse. So MazeSolver, this version of MazeSolver doesn't require us to pass in the starting coordinates. So apologies, the other change that you should make is to get rid of that 0, 0 parameter. We're just going to say, we just want to solve. It's got the maze already stored in it. So we're saying, try to solve it. And so traverse is going to return a Boolean value.
You think we should, on line 44, we get rid of the 0, 0?
Get rid of the 0, 0, yeah.
Okay, cool.
And it will just tell us if it's true, it's going to say the maze was successfully traversed. Otherwise, there is no path through it.
And all that's doing is just a simple logic check. That's not really doing much of anything else. It's just making sure it can get through the ones.
Correct.
Okay.
Yeah. Okay, so let's get to the fun stuff. Let's go ahead and look at the maze class.
Oh, and Casey, we removed I noticed we removed the last row, the last row of the array as well, the two-dimensional array. And is that because the last row is just a blank line?
Exactly that. Yeah, the last row is just a blank line, so that could throw things off. So we take that one out too.
Okay, great.
Okay. So let's walk through this, and I put comments in. I want you all to sort of help me code this. I've given you the stuff that sort of requires explanation, and you can help me with the rest. So we say class maze. The only data that this maze object needs to store is a grid. And it's a grid that we're going to modify as we go, right? We're going to mark it. Like if you were a person walking through a maze blindly and you went through a space and you realized, okay, this space over here is a wall, you want to mark that so that you don't try to look at that space again. So that's how we're going to solve this, by like marking this grid and knowing, sort of accumulating the information that we acquire by looking at different spaces within the grid. So we have our constructor, and this is how we mark the grid. And this is an awkward thing. This is an easy thing in Java. In JavaScript, I had to write this kind of weird code. Static get tried return 2. Suffice it to say that if there is a square that we have tried, so it's a square that we've already looked at, we want to mark it with a 2. And if it is a square that we have, this is weird. Let's see, return 2. Somehow I've gotten away with this so far. Let me fix that. And if it's a square that is in our solution path, then we're going to mark it with the number 3. So that's what this code here is for.
Casey, could you remind us what the get keyword does for us?
It means that we are going to be returning a value. But yeah, Matilda, I haven't actually used it in JavaScript aside from I kind of looked up how you could, basically the code I looked up is how can you replicate a Java constant? So I don't know, maybe you have a better explanation for how that get works.
Yeah, I definitely don't use getters on my day-to-day. I think it allows you to return the value. So it allows you to return this value that the function returns, but you don't need to like I think you don't need to like explicitly like invoke the function with parentheses. I think you can just call like if this, so this is on the maze class, so I think you can just call maze dot path and no parentheses after it. I think that's how the syntax works out.
That is definitely true. So yeah, we'll see that in a second here. So let's go ahead and, so for try position, the only objective, it's a one statement method here, and we just want to mark the square at row column as tried. All right, so try to write that line of code yourself, and then we'll check in. Remember that the fundamental thing that we're working from is the grid. And since it's a grid that belongs to this maze, we're going to start with this dot grid. Any thoughts to the rest? Give you a second. Okay, so this dot grid means we're talking about that two-dimensional array that is being stored inside of the maze object, right? So if we want to refer to a specific square, if we want to refer to a specific position within that grid, then we need also to reference a row and a column. And those are the values that are passed in as arguments to this try position method. So this method is saying, hey, mark this row and column as something that we've already looked at. And we can do that by saying this dot row, or this dot grid row column is assigned the value of maze dot tried. And like Matilda said, like, you don't have to call this as a method. It's a little bit obscure to me, but I guess that keyword get allows us to just treat this as a constant. So fundamentally, all we're doing is we're just within that grid. Remember how it was zeros and ones? Anything that gets called on with try position is now being changed to a 2, right? That's our way of keeping track that we have looked at that square.
Just to go back, you mean like the 0 or 1 in the text file would now be referred to as 2 or 3?
Correct.
In this case, 2.
In this case, 2, yeah, exactly. How about get rows? Get rows is just a getter method, meaning it's just delivering back a value. So we can start with a return. And how do we get the number of rows in this two-dimensional grid? First of all, how do we refer to this grid?
This dot grid?
This dot grid, yeah. This dot grid. And if we want to know the number of rows, remember a two-dimensional array is really just an array of arrays. So we need to ask ourselves, what's the length of the original array? So we just say return this dot grid dot length. And then get columns. Again, it's a getter, so we're just returning a value. Returning a value. I'm going to say this dot grid. And
I could be totally wrong. I'm just guessing. Is it like this dot grid and then you take like the first one and then take bracket 0 or whatever, and then dot length.
Exactly. Yeah, you just go with the length of that. You could go with any row because we know that this is going to be a symmetrical grid, or at least we have confidence that this will be a symmetrical grid. It's probably something we should check for eventually. But we know that the length of any row should be the same. And so we just ask, well, what's the length of that first row? And we ask for the length of that. Okay, and marking the path, this method should probably be placed next to try position because it's essentially the same method, except we're not marking it as tried. We're marking it as part of the solution. So I'm just going to copy that code and we'll say this.grid row call is assigned the value of maze.path. Okay, valid position. We need to know, right? If we're just given rows and columns, those are just numbers, right? So we could potentially, if we're looking at the surrounding squares, we need to make sure that we're not looking outside of the grid. We need to make sure that we're not looking at cells that we know to be walls or cells that we've looked at before. Let me take a quick break from the code for a second, and we can talk through the logic of how we want how we're going to be solving this. So let me get back to my little PowerPoint here. Let's put this in the show. My Google Slides. All right, so how are we going to solve this? Basically, the logic of solving is going to go something like this. We're going to be perpetually asking ourselves, have we solved this? And what's our definition of solve for this maze? We got kind of this moving thing called position that we're keeping track of the cell that we're presently looking at. And obviously we start by looking at 0, 0. How do we know when we're done?
Assuming, I mean, in this case, it's the truth. I'm not sure the rest of them, but it looks like the end would be if we reached the very bottom right cell.
Exactly.
If the end is always the bottom right. I think it looks like it is.
Yeah, but our definition of maze is the end point is always the lower right hand corner.
Yeah, so if we can successfully get there, then it is solvable.
So if we find ourselves in this square, it means that we have won. We have gotten through the maze. Right? How else might this maze solver expedition turn out? Right?
You mean like it could turn out unsolved? Like
it could turn out unsolved. Yeah. So how could we identify that? That's
I guess that it's tried all available paths and did not mark the bottom right corner as tried.
Yeah. So we never get to that bottom right corner. And at a certain point, our stack is going to be empty because we put all of the positions on the stack and we never actually get to the bottom right. So those are the two possible outcomes. So our code is going to read something like, while we haven't reached here, and while our stack is not empty, and in the meantime, we are going to be checking this square. And if that's not the solution, then we are going to move on and check the 4 surrounding squares, right? So this square, we're going to try to add in the square that's above it. Is that going to be read as a valid square if we do things correctly? No, because it is out of bounds, right? This square over here is not going to be a valid square because it is an obstacle. This square down here is a valid square. So guess what we're going to do with it? What are we going to do with squares that we identify as valid?
That'd be a path, marking as a path.
Good. Okay. We're eventually going to mark it as a path. But what else are we going to do? Every square.
Check the squares around that one.
Eventually, yeah. Okay. So Sean, you're nailing it. These are things that we are going
skipping a
to
step.
be doing. And the way that we are doing it is we are adding the square to the stack, right? Okay. So boom, we check this. The gig isn't up, but we haven't solved it. So our next step is to add all of the legitimate squares that surround it to the stack. So this one not valid, nothing added. This one not valid, nothing added. This one is valid, so we add it to the stack. And then this one also not valid.
The stack is only going to hold paths. It's only going to hold actual paths we can travel down.
True, yes.
Okay.
Yeah. Good. Although not quite. It's going to hold all, it's going to hold tried. It's going to hold all the values that are tried, but they won't all necessarily belong to the path, right? For example, once we're on this square, right?
Right.
Now our stack is going to contain just this square. So now we're going to check the 4 surrounding squares here, right? Since this one is not a solution, we're going to check the 4 surrounding squares. Is this one going to be valid? Should this one be added to the stack?
I mean, no, I guess it shouldn't because we don't want to backtrack, but.
Because we have marked this one as tried. And that's one more criteria, right? We add it to the stack if it is in bounds, if it is not an obstacle, and if it is not tried. So we don't add this one. Do we add this one? Yeah, we add this one because it meets all of those criteria. It's in bounds. We haven't tried it. Did I say 3 criteria? 2 criteria. It's in bounds and we haven't tried it. So we put it on the stack. How about this one? Did we put this one on the stack? We do.
Yeah.
It meets the criteria. And this one is out of bounds, so we don't. So now we have 2 things on the stack. First on the stack is going to be this one. So we check this one first, right? And at this point, this one is going to be marked as completed. So we're going to add to the stack. We'll check this one. We'll say not this one. The one to the right, we're going to add to the stack. The one below it, we're not going to add to the stack. And the one to the left, we've identified as tried. And I haven't colored it green, but we know that we've already looked at this one, so we won't add it to the stack. Okay, hopefully you get a gist of what we're doing here. I just wanted to show you the basic logic of MazeSolver so we understand which values we want to be considering as valid. So let's get back and let's write this code. Valid position, the first thing that we check is this position in bounds? So take a minute individually and try to write that code, right? it's an if statement, and we have to validate both the row and the column. So it's kind of lengthy, but that's all I want to say. So let's just take a minute and then check back. All right, I'm definitely running long, so I'm going to try to speed things up a little bit. Can we talk about validating the row first? What needs to be true for the row to be a valid row within this grid?
It would have to be within this grid, that length, right? So it can't be bigger or smaller than that.
It has to be less than this grid.length. Good. And what else? What prevents it from being sort of to the left of the, or sorry, above the top row? What's the lowest row we can have in an array?
You mean like at position 0?
Yeah, good. So we want to say if the row is greater than or equal to 0 and the row is less than this grid.length, right? Does that make sense to people? And then we need to do the same thing in terms of the columns. We need to make sure it fits within the column. So we're going to say, and column is greater than or equal to 0, and column is less than this grid for the given row. Length. Does that make sense? Nod your head, give me a thumbs up if that makes sense. Okay, good. All right. So we've now confirmed that we're within the grid. The next thing we need to check is that it is not blocked. Okay. What was our symbol for obstacle in the text file?
0.
0. And what's the symbol for tried?
2.
2, right? So actually, what can we say about every square that we want to actually look at? It's not 0 and it's not 2. And there's only 3 possibilities right now. So we can just say if.
Meaning like if it's 1.
It's 1, yeah, that's what I'm going for. If this grid row column double equals, I'll put a space in there, double equals 1.
So I have a quick question here.
Mhm.
Wouldn't that line alone really take care of the first 2? I mean, if you try to find something there and it's out of bounds of the grid, it would return like a null or undefined, I'm guessing. So I mean, really, I think just checking for a one would be all you'd have to do. Maybe I don't know.
You might be right. You might be right. This might be one of those things where sort of like, line for line translation of Java to JavaScript leads you to some inefficiencies.
Yeah.
Yeah, in Java, you have to be very careful that you like don't look at something out of bounds, as that will cause a
Oh,
runtime
okay.
error.
Yeah,
Um,
because I mean, it might. That doing those checks on 31 and 32, I guess, could save some time. I mean, it means it's not even going to try it. It's not even going to run the lookup. But okay.
yeah, well, I'd be curious if you have time to test that out and see if we can get rid of some of that code. I'd be curious to see
Yeah, I'll give it a
uh,
whirl.
if you're right. Does that make sense? All right, so we've done the two checks, right? It's in bounds and it's a one. So we can say that result is assigned the value of true. And at the very end, we want to return the result. Okay, so here's our method that decides basically whether we're adding a position to the stack or not. Right? Do we add to the stack? That's really what we're trying to answer. All right, so we're going to save that up. And I think that's all we need for. Oh, one more method that we probably want to put in, and I'll just drop this in real quick, and I'll post it to the chat too to speed things up a little bit. Is a toString method. It is helpful to be able to look at the grid in real time. So as you're making changes to it. And so adding a method called toString, which just allows you to print out the grid as a string, is helpful. So let's see, drop this in the chat here. There you go. So I'll give you a second to copy that down. All right, can everybody hang out for another 15 minutes? Sorry, I should have known that
Yeah,
this would take
sure.
longer. It always takes longer.
It always takes longer.
It always takes longer.
I actually gotta head out.
Oh, okay. Sorry, Ida. Well, I'll post the solution and send it to you.
Thank you. It was
Okay.
great seeing you guys.
Yeah, great to see you, Ida. Take care.
I might have to just go
Clarify,
off
you
camera.
added that. Oh, so,
I was just saying I might have to go off camera for like maybe 5 minutes, just to take a quick call at 11. But I'll be back for sure.
Okay, no problem. No problem.
hey, Keith, just want to verify that code that you just sent. So we're adding that to the end of the maze
Yeah,
file?
yeah. It's just one more method to add in to this maze class, and then we're going to move on. And what we're going to move on to is MazeSolver. Are you all seeing MazeSolver right now? Just want to make sure I'm sharing the right thing. Okay.
Yeah.
And I did a similar thing with the MazeSolver class. I put some of the code in and I put comments for some of the places where I want to work through the code together. So we've got class MazeSolver. And the only data that belongs to MazeSolver is the maze, right? So each MazeSolver has a maze that we are asking it to solve. So we say this dot maze is assigned the value of the maze that we pass in. All right, and here's where the lion's share of the work is done. Traverse. You might remember that we called on traverse back in our script class, right? This is how we actually solve it. And in traverse, we have a variable keeping track of whether we are done or not. We have a position which represents the current position that we are looking at. And we have the stack that we're piling positions on to look at eventually. All right, and let's see. Okay, so we start by pushing on the original position. And I feel like let's see, I feel like I need to do this. Again, we sort of, we have to set things up a little differently if we are solving this with the stack method versus that recursive method that I'm eventually going to show you. So I think we need to start with 0, 0. I mean, let's start with that. So we're starting with the original position in the upper left-hand corner. Okay, here's our while loop. We go until we have identified that we either can solve it or that it is unsolvable. So what are those two conditions going to look like? One should be obvious. One is just based on a Boolean variable that we've established specifically for that purpose.
Well, isn't one of the conditions would be that we reach the bottom right, whatever. So, and that it's a path, so that it's a 3.
You saw the variable, the Boolean is solved that we had made.
Oh, that's right. That's right. That is
So we got that variable, yeah. So we have the variable called done, right? And
right. Forgot about that.
I mean, it's probably an unfair question because we don't see what we're doing with done yet, but done is intended to let us know when we've arrived at the end of the maze. So I'm going to say while not done, and how do we identify that we had used up all of the possible positions and none of them had solved it for us? I'll remember that. Remember, the stack is the place where we are adding new positions to, right? We identify it as a valid position, we put it on the stack. Then simultaneously, we're like moving through the stack and
Right.
popping things off and checking.
So the stack is empty, and we didn't get
Exactly.
to the
So while
promised
we're not done and the stack is not empty. Okay, where are we going to be getting the next position from? I'm going to say pause. This is kind of where are we storing the positions that need to be tried? The staging ground for all of our positions is the stack, right? So we're going to say pause is assign the value of stack dot pop. We're saying, okay, we got this whole list of things that we need to look at. Let's take the next one so we can get through this. And we want to go ahead and mark that position as tried. So let me just copy this. So we're going to say this dot maze try position. It says try position. Arguably, that's not the best name we can have for this, because all we're doing is we are marking this space with a 2. You might remember that try position is a method that we just defined, and it was just that one line method that just puts a 2 at this given X and Y coordinate in our grid. All right, how do we test for victory? For successfully completing the maze, where does our position have to be? Ryan, help me out. Just in terms of even looking at the grid. Where's the end point?
I'm honestly the wrong person to ask.
Okay. I respect the honesty.
You like the bot? You sound like the bottom right.
The bottom right. The bottom right is the end point, right?
Oh, that's right. I actually knew that.
You actually knew that. Yeah. Okay. If we find ourselves in that square, it means we're done. It means that we're done. So that's why the endpoint of this condition is done as assigned the value of true. But the question is, what should that condition look like? And it has to do with the with the positions X and the positions Y value. Right. So we're going to say if pos dot get X is equal to this dot maze dot get rows. Is that what we call it? Yeah, get rows -1. So if we're in the last row and if we're in the last column, right? So I'm going to say pos dot get Y is equal to this dot maze dot get. Say that.
So change those equals to the conditional, to like a triple equals or double equals, right?
Oh yeah. Ooh, terrible mistake.
Yeah.
I'm embarrassed.
It sounds right when you're reading it out loud because it is an equal sign.
I know, but I've been in this game for a long time. Like that's something I see my students do all the time, and I would like to think I'm smarter than that, but I'm not. Good, is a good humbling experience there. Let's see, we call it get columns, I guess. So get columns. Open parens, close parens, -1. So if we are in that final row, final column, we say done is assigned the value of true. And open this up a little wider here. Okay. All right, the else clause. This is the tricky part. This is where we are adding 4 different new positions to the stack. Let's see. And let's do one example, and then you guys can fill in the other examples yourself, right? So we've just identified that we haven't solved it. So the next thing is to add those 4 surrounding values once we've confirmed that they are legitimate. So we're going to say this dot push new pause, which is a method. Oh, wait, let me see. Oh, here we go. Somehow I dropped down here. Well, let's write that method first. Okay, so else add the 4 surrounding positions to the stack. And we want to do that. Obviously, we need to confirm that they are legitimate spaces before we do that. So let's write the push new pause. Oh, and it looks like I've given it to you. Is that right? Do you all have this full method? Do you have push new pause?
It's created, but there's nothing in it.
There's nothing in it. Oh, okay. Well, let me just give it to you for sake of time, and we'll
Yeah.
walk through it. Oh yeah, you're not seeing it. Okay. I'll start by putting it in the chat, and then we'll talk through it. All right. We have our stack, and the question is, do we want to add this value to the stack? The value is identified with its X and Y coordinate. Here's just some output just for debugging purposes. We create a new position. With that position, we set its X value and its Y value. And now we ask the maze, using that method that we wrote a moment ago, we say, if this is a valid position, then push that position onto the stack. So that's all we're doing. Just important to note that there is some validation occurring, that we're not just blindly putting all 4 squares onto the stack. This call to is valid position is asking the maze that question, are we in bounds, and are we, is it an empty space? So that's what's happening there. Okay, so that having been said, let's go to this else clause. We're going to say this dot push new pause. We're going to say pause dot get X minus 1 pause dot get Y on the stack. All right, now given that the current position is going to be at value X and Y, what's being described by the position that we're passing in here? If we're taking our X value minus 1 and giving the current Y value, then which position are we actually testing here?
So it's checking your left box right now.
Checking the left, exactly.
Yeah. And so really, all you're doing in your else clause, you'd be doing 4 of those, right? You're just gonna check all 4.
I'm going to check all 4, yes.
Okay. Okay. Cool.
Yeah. So go ahead and do that. Go ahead and make it so that you are adding the other 3 positions.
Casey, thank you for doing this. I'm gonna have to go though.
Okay, Ryan, no worries. I'll post the rest of the solution right now. Actually, I'm going to drop this else clause right now. If you have 2 minutes, you might want to copy it, and then you're pretty much done.
Okay.
I also have to get going. I have to make myself some breakfast finally.
Oh yeah,
I'm
get some
gonna take off, but definitely keep the Zoom room as long as you need. I'm not going to use it today,
Okay.
so feel free to stay here as long as you need.
Awesome. Well, thanks for sending us out, Matilda. Appreciate it.
Yeah, of course.
All right. Yeah, I'm looking to wrap things up here too. Sorry.
Thank you.
Okay. Thanks, Ryan. All right. So I'll go ahead and copy my else clause over. All right, position to the left, position to the right, position above, position below. Now, actually, this is probably not optimized, not to go off on too much of a tangent, but if we're starting up at the upper left and we're trying to make it to the bottom right, we might want to rethink the order that we're checking these things, right? Does it make sense to start checking to the left? Does it make sense to start checking above before below? I would say probably not. So ideally, you might sort of be checking to the right and below, because those are the paths you're going to need to take to eventually work your way to the bottom right. But this will still work.
I was just thinking, but even if like, look at it, because I thought about the same thing, it's still going to end up checking all four for the most part though, right? Unless.
No, because you don't always check every square, right? If you find a path, right? Like imagine that you had a straight line going to your right, and then you had just had to drop down one in order to get to the solution, right? Better to be checking to the right, to the right, to the right, to the right, maybe have other stuff mounting up on the stack. But then once you do that initial drop down, you're done. And all of the rest of the stuff on the stack will just get ignored because like you found the answer. So it makes sense to do the things that are most likely to lead to a resolution first, which means that maybe some other things don't need to get done. Does that make sense?
Yeah, so I'm guessing if it checks to the right and it's a valid path, it's not even going to check. It just keeps moving, right?
It will keep moving for as long as it can until it hits a barrier. And then it looks back on the stack to see what needs to be done. All right. So this is pretty much it. This should give you a viable solution, hopefully with the HTML and CSS that you have. Hopefully it all works. Remember, although I built this within JS code, that really all you need to do is to open up the index file in your browser. And let me know what you see.
When I like upload the file, it's just still showing like a gray square. It's not really like.
Yeah, check if you look in your console. The index, go to your index HTML. You have to comment out the one that's loading up MazeSolver 2.
Yes, MazeSolver 2.
It's trying to load that and then just.
Sorry, I left some of the stuff. From
Yeah, that's no problem.
2.
I'm getting an undefined error, but I'm following it to see where it's at.
Okay.
Yes. 28. It's because I did mine a little bit different. I tried that thing earlier when I asked about just checking for one. So I can fix that.
I'm still getting an error. I'm getting cannot read property length of undefined. Maze
That's what I'm getting to right now. I'm kind of chasing it down in mine, but
And why don't you share your screen? Let me stop sharing.
Are you sharing yours, Sean?
mine may not be best because I did one of the steps a little bit differently when I was trying to see if it would work. So um, you might want to try yours right now.
So that's the error in the console right here. And when I go to, it says Maze 52. But when I go here, this is the only thing I get.
I'm expanding that so I can see it. Cannot read property length of undefined maze.to string. Maze 52. It's not good, that length. Length of undefined.
This dot grid, but that's not the same thing it's showing here. But
Right, it's saying the grid is undefined. Why would grid be undefined at this point? Script 40. Yeah, go to script.
that doesn't even make sense because I have a console log there.
But you're calling on maze to string. Okay, so where are we loading up maze? Okay, grid.
So I just comment this out.
For now, yeah, because you don't need to actually show it as a text file. We'll figure that out later. See if we can get the HTML to show.
Yeah, no, it's still good to me.
I gotta head out too, but just want to say thank you and appreciate your time for teaching us this. And nice to see y'all again. It's been a while.
Yeah, all right, Drew. Good to see you. Thanks for coming.
Yeah, take care.
Oh, I've got some missing curly cues in the push new position method. I don't know that you copied in the chat.
Mhm.
So it's in MazeSolver at the very bottom. There's an if condition at the bottom, but I don't have any curly cues around it.
This one here.
Yeah.
Oh.
I don't immediately know, and I actually have to run off, but I will send the entirety of this code and you can sort of square it with what I send you. Sorry that I
Yeah, no,
don't have
that's
time to
great.
debug it.
Oh, that's all good.
Was
It
this
was really cool to see this laid out and like how to approach it.
Yeah, I think like I know it's a lot to take in. I think for those folks that like look it over again and like work through it to process it, that this will be helpful. But otherwise, it's kind of a big chunk to take on at once.
Yeah, I think I think all the extra graphical stuff just is making it like I want to try it again now and see if I can just get it with the grid and just get it like solvable or not, you know, and then start there and then try to get the graphic stuff.
Yeah. Well, and so I don't know if you guys would be interested in doing like another presumably much shorter session where I do the recursive solution, because the recursive solution is the one that will actually like show you how to solve it. The unfortunate thing about the stack approach is it just lets you know like, hey, you got out, but then you can't really identify what the path was, because you know, it's sort of simulating like you're stumbling through, and they're like, hey, you found your way out. Like, well, could you find your way back? No, but the recursive way, you are sort of leaving breadcrumbs and you can trace your trail all the way back. So if you
Okay,
guys,
cool.
I can either just post that code, or I could do like a 20-minute thing like next week to just walk through that recursive solution. You don't have to let me know now. I'll propose it and see what people think.
If you do it, I'll be there.
All right, cool.
Honestly, any of this
This
stuff
is
is
fun.
helpful.
This is fun.
Honestly.
Awesome. All right, well, thanks guys. Thanks for sticking it through to the end. And
Sure.
yeah, hope things are going well, and we'll be in touch.
Thank
Okay.
you.
Thanks,
Okay.
Casey.
Bye guys.
We'll see you.